Welcome back to G-Will Mathematics. In our previous lesson, we delved into finding the adjoint of a 2 by 2 matrix. Today, we will be evaluating the determinant of a 2 by 2 matrix. Let's jump right in. So the determinant of a matrix is written in the abbreviated form dt with the name of the matrix written in the parentheses or indicated with the absolute value sign. Let us consider matrix P with elements A, B, C, and D. Please note that AD represents the leading diagonal and BC represents the non-leading diagonal. So, to find the determinant of a 2 by 2 matrix, we are simply going to take the difference between the leading diagonal and the non-leading diagonal. Kindly note that when the determinant of a 2 by 2 matrix is equal to 0, the matrix is singular. While a non-zero determinant indicates that the matrix is non-singular. Let us look at a few examples. Let's take matrix F with elements -4, -5, 7, and 8. Please recall that -4 and 8 represents the leading diagonal and the -5 and 7 represents the non-leading diagonal. Let us find the determinant of this 2 by 2 matrix. So, let us take the product of the leading diagonal. -4 times 8 gives -32. And the product of the non-leading diagonal, -5 times 7, is equal to -35. So the determinant would be equal to 3. With a determinant not equal to 0, matrix F is deemed non-singular. Let us look at another example. At this time, I would like for you to pause the screen for 15 seconds and answer this question. Fantastic. What did you get for your answer? Let us figure it out together. So remember, to find the determinant, we are going to take the difference between the leading and the non-leading diagonal. So in this case, our leading diagonal is 6, 2, and 6 times 2 is 12. The non-leading diagonal is 1 times 12, which gives 12. So gives a difference of 0. In this case, since the determinant is equal to 0, then we can say that matrix C is a singular matrix. We have come to the end of another lesson. In our next lesson, we will be looking at obtaining the inverse of a 2 by 2 matrix. Don't forget to like, share, subscribe, and leave a comment. Keep dreaming without limits. Until next time.